Hi, welcome to video 2 of section A4, the cardiac system in a single bout of exercise. In this session we're looking at cardiac output, heart rate, stroke volume and the relationship between them. So what is cardiac output? It's essentially the amount of blood that leaves the heart in 1 minute, and it looks at what comes out the left side. The reason we look at what comes out the left side is because that is the side that pumps the blood around the body. The right hand side, what we'd know as the blue side, carries deoxygenated and returns it back into the heart to then take it through to the lungs. But we're concerned with the left hand side that takes it round the body. It's the stronger half of the heart as well, because it's got to pump the blood over a bigger distance and further away. So cardiac output, it's represented as a Q, but it means cardiac output, the amount of blood leaving the heart in 1 minute. So they're the two areas. 1 minute refers to heart rate and the amount of blood refers to the stroke volume. So heart rate is the number of times the heart beats in 1 minute, and we represent that as BPM, beats per minute. Stroke volume is the amount of blood that comes off the left ventricle, out of the left ventricle in just one contraction. So the ventricle is about here on the left hand side. So it's the amount of blood that's pumped out of there in one single contraction. So during exercise, cardiac output will increase. It increases for two reasons. One, that heart rate increases. We've spoken about the anticipatory rise, the fact that heart rate increases prior to exercise, and we know that heart rate continues to increase for the same reasons as breathing rate, because we've started moving, we've started making an increase in carbon dioxide, we've started using oxygen, and those chemoreceptors are picking all that up and working in the medulla together with the cardiac control centre and the respiratory control centre to try and get more oxygen into the body and carbon dioxide out of the body. We know that this heart rate increases and corresponds with the amount of exercise that we're doing, the intensity of that exercise or the demands of the exercise. So if exercise is very demanding, very high intensity, heart rate will increase further. If it's light exercise, then heart rate will only increase a little bit. The body will only increase the heart rate as much as it needs to supply that oxygen and rid the body of the waste products. Stroke volume also increases with exercise, or with the demand of exercise. Now there's a limit on how much stroke volume can increase. There is obviously a limit in heart rate, but it's quite high. It's usually 220 minus your age would be your maximum heart rate. Stroke volume will increase gradually, but not to the same extent. And this is limited by the ability or the strength of your ventricle, of your heart. So let's now consider how stroke volume increases. So when the heart is relaxed, the ventricle specifically, it allows blood to flow in from the atria. If we are exercising, the venous return will increase, which means more blood will flow into the atria, which means more blood flows into the ventricle during its relaxed period, because it's going at a faster rate. If the heart is contracting more frequently, not only are we pumping out more blood every time it pumps, so stroke volume has increased, we're now increasing the number of times per minute it's contracting, so therefore we've increased the cardiac output. So let's have a look at some resting values. Now for your exam you will not be examined on the numbers. You may need to read a table and identify that this is heart rate, this is stroke volume, and this is the average amount of cardiac output, but they would give you those numbers. So let me just put this into some sort of perspective here. We've got resting values. Heart rate is approximately 72 beats per minute. Stroke volume approximately between 70 and 90 millilitres. So to calculate the cardiac output, which is the heart rate times the stroke volume, so it's the number of times the heart beats per minute multiplied by the amount of blood coming out of the left ventricle with each pump. So that calculation is 72 times 70. So I took the lesser of the two numbers there for stroke volume, and we come up with 5,040 millilitres, or rounded down to 5 litres, and that's per minute. So to put this into perspective, I've given you a bucket here. It's about a half full bucket, 5 litres. So a bucket's usually 10 litres. So a half full bucket of blood every minute goes around the body during rest. To put it into some perspective for exercise, and I was looking at aerobic exercise, so the one where we're going for a run or a jog, we'd look at the heart rate. So heart rate could be up to 180 beats per minute. That's very intense exercise, but this is just for purposes of showing you how much it could increase. The stroke volume can go up to 120 millilitres. We'll talk about how it increases in due time, but it is to do with the fact the ventricle stretches just that little bit further than it used to. I'll come back to that. Cardiac output now, if we use the same multiplication, so 180 times 120, comes out at roughly 21.5 litres. So if each bucket is 10 litres, we've got 10 litres, 20 litres, and a little bit out of the green bucket. So that's 2.5 buckets. The amount of blood that can be pumped can go up to 4 buckets or more, depending on how fit you are and how healthy you are. So the fitter you are, the higher your beats per minute can go. The fitter you are, the bigger your stroke volume will be. And therefore, the more blood you can pump out in 1 minute. The more blood you can pump out in 1 minute has a benefit, because that's oxygen in those buckets. It's getting rid of carbon dioxide in those buckets. So it essentially makes your respiratory and cardiac system, your aerobic system of exercise, extremely efficient. So let's look at Starling's law. This is how stroke volume increases, essentially. So Frank Starling discovered how stroke volume increases during exercise. And this is what he discovered. Blood returning back to the heart, and it returns by the veins, okay, like the vena cava, for example, is called venous return. So venous return, the amount of blood returning back to the heart through the veins. That's venous return. Be familiar with that term. As heart rate increases due to the physical demands of the exercise, blood flow and venous return also increases. So if your heart is pumping blood if your heart rate is pumping more blood out of the heart, then more blood is going to return back into the heart, because our circulatory system is a closed system. So venous return also increases as heart rate increases. The second thing that happens is you can increase the stretch of the chambers in your heart. So we're looking at that left ventricle again, but this time, instead of it only stretching this far that it does in rest, in exercise it stretches quite a lot further. And as I mentioned before, depending on how often you do this type of exercise, depending on how often you put your heart muscle under this stress and strain, will impact how big it can stretch. And if you do this exercise very often, the heart will stretch a lot further. If you're not very healthy and your heart isn't used to stretching, then it simply won't. So you won't be able to get the benefit of a large stroke volume. So we've increased the stretch of the left ventricle specifically here. And if I've increased the stretch, I've increased my relaxation phase, my what we call diastolic filling. So now, instead of just pouring the blood into this tiny little ventricle, I've got the blood to pour into there, so I can actually put more blood into it, so I can fill that bucket up a little bit further. We call this greater diastolic filling, but what it means is when the ventricle is at rest, we can pour more blood into it, and with increased venous return, more blood is available to go into that further stretch of the heart. So as the heart is stretched further, now it will contract with more force, hence the rubber bands there. So if you think of a rubber band, if you pull the rubber band just a little bit back and let go, it's not going to travel very far. If you pull the elastic band as far as you can and let go, it probably would go to the other side of the room. This is the same as your heart. If your heart stretches a little bit, it contracts with some force. If your heart stretches a lot further, so going back up to this picture at the top, then it will contract with more force. That means the blood is going to come out of the heart a lot quicker, which means it can go back into a resting phase much faster and get filled much faster. If you are stretching further, filling quicker and contracting faster, your cardiac output is going to increase, and also your stroke volume obviously is going to be increased as well. Hope that makes sense. So Starling's law in a nutshell, stroke volume increases due to increased venous return. Due to increased stretch and contractility of the heart means more blood is pumped out of the heart. I hope that makes sense for you. There'll be video 3 coming up shortly.